Welcome to part 2 of building advanced RAG. Here we will see how we can create custom node parser. The idea is like query on a smaller chunk, but in return pass the bigger chunk or the parent chunk to the large language model. In the previous video, we have seen that how we can achieve this functionality using hierarchical node parser and auto merging retriever. This is how hierarchical node parser create the parent and child relationship, where if we have got 50% of the child nodes in auto merging retriever, then only it will give us the parent node of 512. And similarly, if you have got 50% of this 512 child node, it will give you 1024 parent node. But ideally how we want is like the right side of the figure, where whatever child node we get while querying, whether it's 256 or 512, always we should return the bigger parent node, which is 1024. So first we will see how we can convert this hierarchical node parser plus auto merging into this kind of a structure by choosing the threshold of 0. Secondly, we'll see how we can create our own custom node parser which can achieve this functionality, and then we'll see how we can extend this functionality to more general level. So let's get started. So first, on this video, we'll use Llama version 10, the newly released version of Llama, and they have done a lot of changes. So you can just visit this blog which explain what all changes they have done. So let's first install the package. So we are installing all the packages. Then we are downloading the data, the same PDF file which you use in part 1. We are using the same. Then we will import all the required packages. So we're importing these packages. There's one weird error which we are getting in the latest version of Llama. There's some circular error which while importing these packages. So if you get this error, just rerun this cell again. You will not get this error. Then we are just loading the data and then creating a just extracting the text out of it and then creating a docs list which is of document type. I'm just filtering in first two indexes because they refer to the contents with page number. And then we are just downloading our Zephyr model from HuggingFaceLLM, and then we are using the same BG small embedding for our embedding model. We are downloading it using HuggingFace embeddings. And if you see in the latest syntax of LlamaIndex, we are just setting everything like settings.embed. It will become like a global parameter. We need not to pass it every time. Then so first create a hierarchical node parser. We have done in our previous video also. So same thing, we are doing it again. And then we are creating a VectorStoreIndex where we're just passing the leaf node, and then we're getting a base index out of this. Then auto merging retriever. So the only change we have done, we have chosen the threshold of 0.0. By default it's 0.5. So it looks for 50% of child nodes. If we get, then only it will give the parent node. Now by setting threshold of 0, so whatever child node it will give you the parent node, and if that parent node is also a child node, it will give you the main parent node, which is the bigger node. In our case it would be 104. So suppose if you got 256, it will return to 512 because threshold is 0, and as we have written 512, it will give you 1024 until we return the main parent node. So we're just creating an auto merging retriever. We're calling it as retriever. Then we are passing it to retriever query engine, and we are creating a query engine out of it. So let's test our RAG. Added few more questions, and we'll test it. In next video, we'll see how we can test this complete retriever performance automatically by generating around 200 odd test cases automatically. So that I will cover in next video. So for now we have this set of around 7 to 8 questions. So let's run each question one by one, passing it to query engine and checking the response. So if you see, for every time as I've done verbose equal to 2, it will print the internal info also. So you see every time is merging the nodes into the parent nodes. It's giving you the parent node only every time. So let's see the answer. It got the first answer correct, and most of the answers it's able to fetch it correctly, like this one also, and this one also. And if you see every time it's merging it to parent node, and that's because we have chosen threshold of 0. This is also correct, and yeah, this is also correct. And for the new question also, it has 159 as the fiscal deficit for 2023 and 24. This is correct. And for next question, yeah, mission life, it has got the information right. And potential of energy, this is also correct information. So it got all the answers correctly, and every time it's returning as a parent node. So we are querying on the child nodes, but while passing to the large language model, we are passing the parent node. So we achieved what we wanted. So next, let's create our custom parent to child node parser. I'm calling it parent to child children node parser, which where we'll all the smaller child nodes will refer to bigger parent node. So first, let's create a class of parent to child node parser. We are inheriting the node parser, and then these are a set of parameters like we are passing, like what is chunk size, what is chunk overlap, and then what it's doing is like it's creating a map of node parser for every id, like for 204 it creating one sentence splitter, similarly for 512 128. And then so we call this function, like after creating this class we call this get nodes from document by passing the documents. And what it will do is like for every document it will just call this get nodes from doc function, which is written here. And what it does is like first it will for all the document it will create the base node, and using our index 0 parser, which is the parent parser. So it will create a size of 2048 chunk sizes, which we call as our base nodes. And then what we are doing is like we're just converting the IDs of each base node into a fixed format, like node 0, node 1 and all, so that it becomes easy for us to test the performance of all the retrievers, because every retriever is pointing to the same ID. And secondly, it helps us to visualize whether we got the parent node correctly or not. We'll see later. And then what we're doing is like for every parent node, like base node, we are just looping it through every other parser, children parser, like level 1 and 2. And then we are creating sub chunks, or like the child chunk for every parent node. So first it will do 512, then 256, and then we are just converting into an index node where the each index node is referring to our parent node. So node is here is the parent node, so it's referring to the parent node ID, which is helps in doing the lookup. And then we are just storing everything into all nodes, which is getting returned. And then we just create a dictionary also of the base node with the node ID and the node as the value. So this is the quick class which I have created, parent to child node parser. So let's call this child class like parent to child node parser by passing. So we are passing the chunks like sizes like 1024, 512, 256. So 1024 is the parent node, and 512 and 256 the child nodes. And once creating object, I'm calling this function get nodes from document by passing the documents, and it will return all nodes which will have all the child nodes, and all base node dict which will have the base node ID and this base node ID and the node itself. So next, what I'll just pass all the nodes into VectorStoreIndex, and it will be my, and then I will be calling it as a retriever, creating instance of it, and I'm saying top 3 here. Then this retriever is passed to recursive retriever. So recursive retriever is helps us to traverse all the node relationship, whether we want to traverse next node or previous node, or we want to traverse parent node or child node. So it gives us all the functionality. So we call this recursive retriever. We pass the one key which should be same as the retriever key, where we are giving this vector retriever which we have created here. And then this is the mapping which can help us, like for every child node, when it's passed and when we get the referring parent node ID, this can be looked from this dictionary which we are passing here. And I'm setting verbose equal to true. And then what we'll just from this retriever, just we retrieve, call retrieve, which will work as a retriever by passing different question. We can see what all nodes are running. So I just checked for question 0 and see what all nodes we're getting. This is simple helper function which can display the source node. So for question 0, we got node 0 as the parent node with the similarity of this, and this is the complete text. So next what we'll do, we'll just pass this recursive retriever instance into the retriever query engine, and this is our query engine. And then we'll just loop it through and pass every question into it and see what answer we're getting. So as you can see, every time whichever child node it's finding, it's always returning the parent node of it, like node 0 is the parent node, and it gave it the right answer. Then for this also got right answer. Here also the answer is correct. Here we got 2 parent nodes, and the answer is correct. And for nature forming also, this is the correct answer. So yeah, all the answers are correct through this query engine also, like recursive query engine. And the next is we will create parent to sentence node parser. So instead of creating different childs of different chunk sizes like 256, 500, or what I'm thinking, let's create every sentence as my child, and then every sentence should point to the parent node which is of size 1024. So that's what we call, I'm calling parent to sentence node parser, and which is a class. It will take different parameters, like I'm just passing one chunk size. So my parent would be like I want one chunk of size 1024 chunk overlap, and then I'm using SentenceSplitter to create parent chunks out of the doc. And then internally it will call this get nodes from document. I just kept the same structure as my previous class, which is parent to children parser. So internally it will just call this function by passing all the documents. So main crux is in this function. So first what we're doing, for every first we are creating a base node using the parser what we send, like SentenceSplitter, and it will create from this document, it will create all the base nodes of size 1024. And then again I'm just creating a constant ID for every base node. And then what I'm doing, like to split every base node into sentences, I'm using split by sentence tokenizer, which is I'm importing here, which is under nodeparser.text.utils, split by sentence tokenizer. So it will just split my text into a single sentences, and I'm calling it SentenceNodeParser, and then I'm passing every node through it, and then I'm passing the text of this node into this sentence tokenizer. And then I'm creating similarly the index node, and here I have to just for every sub nodes what I got, I'm just referring to the node ID of my parent node. And before passing it to the index node, I'm just creating it as a text node. So I'm passing sn, which is a text, into a text variable, and just wrapping it with a text node. And then everything I'm saving in all nodes. So it will return me all the sentences as a child node, and then my parent node, which is a base node, I'm creating a dict out of it, which just stores the ID and the parent node. So similarly, we'll just call this class, create an object out of it by passing, I wanted my parent chunk size of 1024, no overlap. And then I'm calling this get nodes from document by passing the document. So it gives me all the sentence styles here, and base node dict also. You see we have got 908 sentences, unique sentences. I'm just passing these all the sentences into VectorStoreIndex, and then I'm creating a vector index store index as retriever, top 3 here. And then again we are passing it to RecursiveRetriever. So by through retriever dict, by keys vector, and the vector retriever is the one which we created here. And here I'm passing the mapping of my all the base nodes what I've created. So internally, whenever the child node is we have found, using this index what we have created, where I'm referring to node ID of the parent, it will just search this node ID into this dict, and where for every node ID I have a parent node which I have already passed, so it will return me the parent node. And then I'm passing it to RetrieverQueryEngine, this retriever, and then this is my query engine. So I'm just calling all the questions, passing into this query engine, getting the response. So if you see, I'm getting all the parent nodes in return, and given that I'm searching on the sentences. So this query engine also is working pretty well. It's giving me all the answers correctly, as you can see. And yeah, so this is the second custom node parser which I have created, which creates sentences as child nodes and refers every child node to parent node. So in our next video, we'll see how we can evaluate the performance of all the retrievers what we have created, whether it's parent to sentence or parent to children or the base retriever what we have, and we'll see which one is performing better. So in next video, we'll generate around 200 plus test cases automatically, and then we will evaluate every node parser and see which is performing better. So thank you for watching the video. Please like, subscribe, and do share your feedback. Thank you.